Good evening, class. Tonight we're going to talk about water heaters. And I know that you've seen two videos about installation, and I realize that most, if not all of you, have actually done that and changed out the heaters. But what I'd like to do is go over the parts for the heater, including a little background on the earlier heaters. So, with that in mind, let's talk about history of water heaters. Okay, going back to probably the 1920s, 30s, long before my time, my mother told me that they had a water heater only in the bathroom at the house where she lived. And it was a water heater that had a tank, an external gas flame, like a burner, that you had to light manually. And of course, those are no longer around and would be illegal by today's standards. Now, when I came along, uh, officially into the trade in the 70s, but before that, as a kid with my father in, let's say, the 60s, the water heaters, as we know them now, were around. Uh, but a lot of them were holdovers from the 40s and early 50s. They used copper tanks, and the copper tanks just went on and on. They didn't wear out. And I remember seeing some that were like 20 years old in probably the late 60s, maybe early 70s. And of course, that has changed. Now, today's tanks, I don't think they make the copper ones anymore. And for a while, they made something called Monel, Monel, I believe it was. It was an alloy. It was very durable, lasted a long time, and was worth scrapping. I tried it once, but to get it out of the body of the tank was just too difficult. It wasn't worth it. I don't think they're around anymore either. Uh, so today's tanks, they're either 5 or 6 years or 10 years. And there's a few ways they get around making them better or not so good. And I remember one heater I put in Newport probably maybe 30 years ago, and it was a 6 year, 5 year. We'll say a 5 year, 5 and 6 or 6 and 12. I'm going to stick with 5 and 10, which is what they had. I'm more familiar with. We'll say it was a 5 year heater. It was a 5 year heater, and to make it a 10 year heater, they gave me an extra anode rod, which we will get into later. And what that did is to slow down the corrosion by attracting the corrosion to these sacrificial rods, is what they're known as. Kind of like on, if anybody here has a powerboat, you know how you put zincs on the shafts and the rudders, anything metal. Again, the corrosion goes to the zincs and they corrode rather than your shaft or your rudder. It works like that, except it's in the tank. So that company made a 10 year out of a 5 year by adding an anode rod. Now, how much more it was to do that if you bought it as a 10 year, I don't know. Another way they do it is to put more enamel on the inside. I went to a seminar on water heaters put out by, it might have been Ream, Rude, one of those national companies. It was at Venus many, many years ago, probably, again, about 30 years ago. And they went through it. They just take a piece of sheet metal, make a circle, top and bottom, and they have them like a robotic arm that comes in and it sprays a certain thickness of enamel on the tank. They know how much they need to make it last for the warranty, which is, we'll say, 5 years. They'll go 6 or 7. And the 10-year ones will usually go maybe a couple of years over that. If they don't, then you get a free tank. At least years ago you did. Now there's a handling charge, and then of course, you're gonna have to charge your labor to replace it. So they know how to make the tanks very inexpensively, and they're not at all like the tanks go back like 70 years ago that were like solid, copper line tanks. Okay, that's a little background. Also, the insulation on the tanks, two types that I've seen. One, the most common, is the soft insulation, like the Pink Panther, the stuff that we see in the walls of all the houses. The other one is a solid foam insulation, like you might see for PEX tubing, like if it's in the floor and the ceiling, they use that. Very dense, very high R factor insulation. And the good thing about that is the tank doesn't dent as easily if you have it on a sharp edge, like on the edge of your truck or a loading dock or something like that. And it's a more efficient foam. I suspect it's also, I know it's more expensive. So those are the two types of insulation that I have seen. Now, what I would like to do tonight is to talk about electric water heaters first. Now, in the code book, which I have here, they talk about the gas heater first. But I'm going to go with the electric because it's got a few less parts. And for the most part, we'll just, when we go to the gas, we can skip those parts and just pick up where the gas-only parts apply. Okay, so here's what I like to do. I'm going to go over the parts to an electric water heater. I suggest if you have a pencil and paper, or you just want to type it out, if you got questions, write them down. And then when we go live, you can ask them. Like I said, the only drawback to this video is that you can't ask me questions. Nor can I ask you questions either. Okay, so let's start with that electric water heater. Let's start on the outside and we'll work our way into the inside. Okay, at the bottom of the tank, you have the drain. All right, sometimes it's the cheapest looking piece of plastic you've ever seen. It's really only used probably one time when the tank fails and you have to get the water out of it. That's it. So it doesn't have to be something that's used all the time. Now, also on the outside of the tank, it will have the taps at the top. You're going to have a tap for the cold water coming in, obviously, and a tap for the the hot water going out. Also, on the side of the tank, you're going to have a place for the elements. These are two, I believe they're 1500 watt elements that go into the side of the tank that obviously heat up the water, 220 elements. And you can change them and you can get them from the supply house. I believe I've done it a few times. Not crazy about dealing with 220 myself. And usually the tank will fail, at least my experience, before the elements go. But you can replace those elements. Obviously, you got to drain the tank before you take the elements out. And they look like a tube that goes down and back maybe two times, and they're about maybe 3/8 of an inch in diameter, and they fit in a very small hole. I think the hole is about a 1 1/4 inch hole for the upper and the lower. Okay, and the way to tell if one of them gave out is the water will only be, it'll go from say 130 degrees if you have it set that high. It'll drop down to maybe 100 degrees. That means that only one element's working. And I guess you can use a tester to find out which one is not working. Okay, now let's leave that alone. We'll leave the electric alone and go to the part that we're more interested in. All right. Also in the top of the tank, you're going to find something called an anode rod. Okay, it used to have its own tap. They've discovered that you can actually attach it to the bottom of the hot water and the hot water outlet coming out. So they have this solid rod that goes all the way up to within a few inches of where the hot water comes in. And then there's a hollow piece of pipe there with holes in it so the hot water can actually go out of the tank and the anode rod can hang from that. And it saves them some money on another tap. We never did put the anode rod in. In fact, the only one I ever did was the one I mentioned earlier, where I had to add an anode rod to a special hole to make it a 10-year heater. It's the only time I ever touched the anode rod. Now, I've seen anode rods that have been taken out. In fact, I think I took a few out just for samples. And when they go in, they look about like a 3/4, maybe half-inch black steel, about that diameter, like say 7/8 diameter, and about 3 feet long. They go pretty far into the tank. At the end of the life of the tank, once it gives out and starts leaking, that what looks like a solid piece of pipe is now down to like the size of an icicle, maybe 16, 14 inches, 12 inches long, and it comes down to like nothing. There's almost nothing there. It looks just like an icicle. So it corrodes. Its job is to sacrifice itself for corrosion, and so the corrosion doesn't go after the tank, or at least not right away. Now, also in that tank, at the bottom where you tie into the cold water side, it's already installed, so you don't have to do it. There's a very thin piece of plastic tubing that is flared out, so if you reach in there, you can sometimes reach in with your finger and kind of grab it and pull it right out. It just kind of slips in there. And the purpose of that piece of tubing, which is very thin, is to take the cold water and to bring it to the bottom of the tank. The idea of that is the cold water, if you just let it go into the top of the tank, will go right back out the other side because the hot is right next door. So when the hot water is opened, the cold water will be drawn right over to it, and you won't have hot water. The hot water will stay at the bottom. So what somebody figured out was to make the cold water go all the way to the bottom, where it's released to the bottom of the tank and it's heated up, and then it rises up and out of the tank once it's heated. Okay, the name of that is a DIP tube. Okay, get the name of it, write it down. And some of them used to be like open, like an open pipe. The one in the book, the textbook, is a pipe that has a cap, I guess, on the bottom, but it's got all holes around near the bottom. Same idea, right? And I don't see it here, but partway up the dip tube towards the top, there's a small pinhole about the size of a BB hole, so it wouldn't really affect the efficiency of the dip tube. And I think that's for pressure off the tank tried to siphon. That pinhole would break the siphon. Okay, the other side, remember, was the anode rod. Now, the other thing that sticks into the tank, beside the elements, is the temperature and pressure relief valve. Now, this is a big deal. This is spelled out in detail in the code book, right? Which means, of course, you're liable to get some questions on that. Now, this temperature and pressure relief valve, and now we talked about this, I believe, briefly last week. Remember, it's set to trip at 210 degrees, which is 80 degrees higher than legal, which is 130, the legal maximum. So you get to 210, it's about ready to boil, and that's when it will trip out on its own. At least that's what they claim. Also, the pressure it's set to trip at, because it'll trip either way. The pressure is 150 pounds, which also is far beyond the legal maximum, which is 80 pounds. So it's at 70 pounds over. So it's almost double. Okay, so that's the T and P valve. Now the T and P valve, again, I know we went over this, but just a reminder, it has a relief pipe that comes down to within 1 foot of the floor. You want to go down a little further? Go right ahead. But you're not supposed to be more than a foot above the floor. You got a tough inspector, I might call you on that. If you had just like a scrap of pipe that didn't go low enough, we'll say it was 2 or 3 feet off the floor, he could call you on it. Now, one time I was walking by a boiler and I hadn't put the relief pipe on the boiler yet, on the pressure relief valve on a boiler. It works the same way as this, and it trips out at 30 pounds. And as I walked by the boiler, it tripped. I believe I must have been filling it with street pressure, and I exceeded the 30 pounds because street pressure in almost any house is well over 30 pounds pressure. So as I was filling it, I tripped it out and it got me. Fortunately, it wasn't at 180 degrees, which boiler typically is. It was warm. It was hot, maybe like hot water from a water heater. Taught me a lesson. Never leave a relief valve without putting a relief pipe down towards the floor. Whether you're doing a boiler that's not going to be inspected or you're doing a water heater that's also not going to be inspected, whatever you're doing, always put the relief pipe on. And you should get you should get a permit on a water heater too. Right? You got gas there or electric, and you have a potential for either one of those causing you a problem. Also, you don't get a permit, an electrician who wires this for you, if you're not going to wire 220, and I don't recommend that. He might get a permit. And if the electrical inspector shows up, guess who he works very closely with? The plumbing inspector. So my advice is whenever you put a water heater in, do yourself a favor. Get a permit and an inspection. Okay, getting back to the T&P valve. Now that's as far as we went in class the other night. And what I'd like to do is cover a little more about what it looks like, what it does. Okay, looking at it from the outside, it's got a metal tag on it. That metal tag has all sorts of information on it that's covered also in the code book. Excuse me. And what it says is the capacity in BTUs of this relief valve. Obviously, it wouldn't handle a big boiler. And also, uh, it would be, we'll say 250,000 BTUs. It's probably double or triple the size of the water heater we're talking about, the residential heater. So you normally will just, whatever water, when you ask for temperature, pressure relief valve, TMP valve, they don't ask you at the supply house. They just bring out one that will cover just about any water heater you ever do. The other thing that's on the tag is the manufacturer's name, obviously. Another thing will be the temperature that we talked about, 210, and the pressure, 150 pounds, that it trips at. Another thing that we didn't talk about was the length of the element. All right. If it goes in the top of the tank, right, the tap is in the top of the tank, it has to be an 8-inch element. And it says it right on the tag. If it goes in the side of the tank, and it's not electric, because the electrics usually go on the top, in the side of the tank and it's gas, it has to be a 4-inch, because if it's an 8-inch, it hits the flue, the little chimney that runs up through the middle of the gas, which we're not talking about yet. All right. So if it's a 4-inch, it goes in the side for gas. If it's an 8-inch, it goes in the top for any of them. One time, I put in a 4-inch in the top. Again, I was far from a supply house. I was out of town. I think it was out the other end of Dartmouth. And I only had a 4-inch. I was like, forget it. I'm going to put the 4-inch in. Because the 4-inch would work just fine, I'm sure, on the top or the side. So I put a 4-inch in. The inspector, who, this was many years ago, he's not there anymore, of course, he actually looked at the tag and he nailed me on it. He was right. Taught me a lesson. The 4 goes in the side, 8 goes in the top. Okay? So don't forget that. Now that's information, that all of that information is on a little metal tag on the element itself. Okay, the capacity of the tank. All right, is also, of course, on the tank. And before I go any further, any tank that you install in Massachusetts should have a tag on it that says that it's approved for use in Massachusetts. Now, this has been around for a long time. As far as I know, it has never been changed. Okay, so I would suggest that if the homeowner is providing a fixture, or in this case, a water heater, that you make sure that it's approved for use in Massachusetts. Okay, otherwise you get a shop inspector, you're going to be taking it out. It'll be very expensive. You're going to be putting another one in probably for free. Okay, this is a point where I would like to ask if you have any questions so far, but obviously I can't do that. Now, to give you an idea, the ratio of the size of the heaters, how the gas and electric compare. Years ago, an 80-gallon electric was standard for a single-family home. The equivalent of electric in gas was either a 30 or a 40. Years ago, a 30 would do it, but to get the efficiency ratings, I heard through the grapevine that they cut a few corners. It was still a 30, but a 40 was a better choice. So my advice is to, if you're doing electric, go with an 80, unless they specify they want something smaller, and then you could politely caution them that a 40 or 50 or a 66 or whatever they want might be a little small. Okay? The reason is that the electric is slow to heat up. All right? It's and you might want to make a note of this. The recovery rate, right, once you use the hot water, is a little slow. So the no hot water heater can keep up with you drawing the hot water at wide open. That's why there's a tank. So it gives it a little extra help. Once you start drawing hot water, the flame, the electric kicks on, or the flame comes on and starts heating the water. And they've got it sized so that you can use enough water to do most whatever it is. Usually it'd be a shower would be probably where you'd notice that the water was cooling off. So an 80 electric, it's a 30 or 40 gas. Now, as far as which one, you shouldn't have to recommend which you uh, would install. I mean, they're not going to ask you, but in case they do, might happen. Don't recommend electric. The problem with electric is, yes, it's nice and quiet. There's no smoke pipe. There's no gas pipe. There's no open flame. But it costs about twice as much money to operate as gas. Okay, now I think I'm about out of time on this segment. I'm going to turn off and come back on again. We're going to cover the energy guide before we go on to gas. Okay, so let me get this mouse down here. He's running away. Here he is.